Welcome to the Mathematics m-1 channel. Today we are going to solve another interesting integral. Integral from 0 to infinity x to the m minus 1 minus x to the n minus 1 over 1 minus x dx is equal to 5 times cot of phi m minus cot of phi n. Okay, how to begin? Okay, first I am going to take this integral is equal to I, and now we can write I is equal to now I am going to break the limit, so 0 to 1 x to the m minus 1 minus x to the n minus 1 over 1 minus x dx plus, now here 0 to 1, now 1 to infinity x to the m minus 1 minus x to the n minus 1 over 1 minus x dx. Okay, now I'm going to take this integral is equal to I1 and this integral is equal to I2. Now if we take I1, so I1 is equal to 0 to 1 x to the m minus 1 minus x to the n minus 1 over 1 minus x dx. Now we can write here this is equal to 0 to 1. Now I am going to divide it by 1 minus x, so x to the m minus 1 over 1 minus x minus x to the n minus 1 over 1 minus x dx. Okay, then I'm going to write here 0 to 1. Now I'm going to add 1 over natural log of x plus x to the m minus 1 over 1 minus x minus 1 over natural log of x. Now natural log of x get cancelled, and here minus x to the, sorry, here plus because here minus, so x to the n minus 1 over 1 minus x dx. Okay, now this is familiar with us because we discussed about a previous video. Okay, however, how to evaluate this integral? Okay, now I'm going to take digamma function, definition of digamma. So we know digamma of c is equal to 0 to infinity e to the minus x over x minus e to the minus c times x over 1 minus e to the minus x dx. Okay, now I'm going to take a substitution. So if we take t is equal e to the minus x, now dt is equal minus e to the minus x. Also we know minus x is equal to natural log of t. Okay, now we know this is equal to, now t world, so we know limit when x approaches to 0, so here 1 and infinity or 0 0, and here e to the minus x, we know t over x is equal to minus natural log of t, so natural log of t, here minus sign, minus e to the minus x is equal to t, so t to the c over 1 minus e to the minus x t, and here dx. Now dx is equal to, we know dx, sorry, here dx is equal to 1 over e to the minus x t, so we can write here minus 1 over t dt. Okay, now we can simplify this. Here now we can change the limit. When we change the limit, this minus get cancelled, so here 0 to 1, now here minus minus, so we can take minus as a factor, so here minus sign. Now here this t get cancelled, this t cancel, and here we will have t to the z minus 1, so 1 over natural log of t plus t to the z minus 1 over 1 minus t dt. Okay, now we know this is equal to 0 to 1, 1 over natural log of t plus t to the c minus 1 over 1 minus t dt is equal to minus times digamma of c. Okay, now here we know now this is equal to this integral is equal to minus digamma of m, here minus digamma of n, so this is equal to I1 is equal to digamma of n minus digamma of m. Okay, now I'm going to tackle the I2. So I2 is equal to 1 to infinity x to the m minus 1 minus x to the n minus 1 over 1 minus x, here dx. Now I'm going to take a substitution. So if we take x is equal to 1 over t, now dx is equal to minus 1 over t square dt. Okay, now we can plug in here. Now limit change 1 to here 1 over infinity, so 0. Now here we can write x is equal to 1 over t, so 1 over t to the m minus 1 minus 1 over t to the n minus 1 over 1 minus, now x is equal to here 1 minus 1 over t, so t minus 1 over t, so t minus 1 over t, and here dx is equal to minus 1 over t square dt. Okay, then we can write here, so 1 to 0, so 0 to 1, this minus get cancelled, so 0 to 1. Now here t to the m over t, here t to the n over t, also here t, so we know t square, so t square times here t to the minus m, t to the m we can write 1 over t to the m, t to the minus m minus t to the minus n over here t minus 1 times 1 over t square dt. Okay, then we know this t square get cancelled, and now 0 to 1 t to the minus m minus t to the minus n over 1 minus t, and we can take minus as a factor. Okay, then we know now this is equal to minus 0 to 1 t to the 1 minus m minus 1 minus t to the 1 minus n minus 1 over 1 minus t, here dt, sorry, here also dt. Okay, now this is familiar with us because we know here now we have this type of integral. So here the final answer digamma of n minus digamma of n, so this is same as this integral, so we can write now here minus digamma of here 1 minus n minus digamma of 1 minus m. Okay, now we know, sorry, I1 plus I2, I'm going to write here this place. Now I is equal to I1 plus I2, so I1 is equal to digamma of n minus digamma of m plus, now I2 is equal to here minus sign, so here minus digamma of 1 minus n, and here minus, so plus digamma of 1 minus m. Okay, now we know this general case, so here I'm going to take this place. We know digamma of 1 minus x minus digamma of x is equal to pi cot phi x. Okay, now we can take here digamma of 1 minus m minus digamma of m. We know pi times cot of pi m minus, and here we can take minus as a factor, so minus digamma of 1 minus n minus digamma of n, so pi cot phi n. Now we can take phi is as a common factor, so pi times cot of phi m minus cot of pi n. Okay, we are done. If you like this video, please subscribe this channel. Thank you for watching.